Hello guys, welcome back. In this video, we will focus our discussion upon storage classes in C. So first of all, let us try to understand what is the meaning of storage classes. So as per the definition, storage classes are used to describe the scope, visibility, and lifetime, which help us to trace the existence of a particular variable during the runtime of a program. Well, sounds a little technical. Never mind, I'm there to explain it. So, there are three main terms to focus upon. The first one is scope, second one is visibility, and the third one is lifetime. So, let us first understand what's the meaning of scope. See, scope basically means uh, actually, if I try to explain to you in a very realistic manner, then many a times you must have seen in some of your books it's written that this content is out of the scope of this book. That means the content that was actually intended to be covered was not designated for that particular syllabus or for that particular book, because the main content around which the book was written was something else, and if something else had to be included into it, it becomes a part which is not included in your syllabus, so that becomes out of scope. Similarly, over here in case of our programming, scope basically means something which is out of bound of some other block. For example, let's say if we have two functions f1 and f2, then what happens is if there is a variable say I in f1 and another variable say j in f2, then we won't be able to access the variable I via function 2. Why? Because I was declared and initialized in f1 and it has got no relation with anything that belongs to f2. So that's why we won't be able to access I, which is a part of f1, from f2. Similarly, the variable j, which was declared in f2, will not be able to access that variable from f1 because it has got no relation with f1. So that becomes scope. So in that case, what's happening is the variables I and j, their reach or their bounds are limited to the function itself where they are defined. The bound of I is limited within f1 and the bound of j is limited within f2. So they won't be able to interact with any other part of the program which is outside f1 or f2 respectively. So that was about scope. Okay, so basically I and j were local to that function. That is what we call it. I and j have local scope. That means they are local to that particular block where they are declared. Next we have visibility. What does visibility means? It means is, see, visibility basically is very much similar to the English meaning of visibility. Visibility is for how long or for what range of code is your variable visible by the compiler in a particular program. For example, if you have a function call, say again f1, and inside that f1 you have declared a variable say a. So until that function is running or until that function is in execution, that a variable is known to the compiler. Okay, as soon as the execution of that function becomes over, a is completely a stranger. So your compiler does not know what was a, what's the value of a, and where did that a come from. It's completely unknown to the compiler. So that is about visibility. Initially, when the compiler is executing that function f1, the compiler knows that yes, there is a local variable inside this function and I need to use that, or I need to use the value of that variable a. But as soon as the compiler completes the execution of that function, it comes out or it shifts the control from that function f1 to some other place. The compiler becomes unaware of that a because it does not reside in memory of the compiler. So that is about visibility. Lastly, we have the lifetime. Lifetime means Lifetime is an attribute which describes how long some variable resides in the memory or memory of the computer. For example, again let us take that same function f1. Over there what will happen is, until and unless that f1 is under execution, suppose the value of that same variable a over there will reside in the memory. But as soon as the execution is over, the compiler will flush the memory and there will be no value for a. Okay, so again a becomes uninitialized and it attains any random value or any garbage value. So that is lifetime. Lifetime basically means how long does some variable reside in the memory, okay, in the physical memory of a computer, obviously during the execution of a program. So these are the three important terms that form this definition of storage classes. Okay, now storage classes can actually be of four types. We will discuss them one by one. So the first type that we're discussing is auto. Auto is actually a short form for the word automatic. Okay, so as the name itself suggests, automatic, that means this is a storage class that we do not need to explicitly we do not need to explicitly assign any variable storage class. It comes to it automatically. So that is what it's written in the first point. Auto is the default storage class of variables. Note this term variable. Auto is the default storage class for variables, nothing else. For functions or methods, we have something else. So auto is applicable only to variables. For example, if you want to declare any variable as auto, then writing int a would be sufficient. You need not write auto int a. Although the meaning of both of them is same, but then you do not need to write that extra keyword over there. Next, these variables have local scope. I've already explained to you what is the meaning of local scope. The local scope means the reach of that variable inside some block is limited only to the block where that variable was declared. That means it cannot access anything which is out of that particular block, or nobody outside that block is aware of that particular variable written inside some block. So that is the meaning of scope. So automatic or auto variables have local scope. Next we have, these are assigned garbage values by default. Garbage value means any random value. I mean, it can be anything. It is not that every time it will be some fixed value. Actually what it says is that garbage means anything rubbish, anything which is of no importance. So these garbage values are any values, which do not have any significance as far as the program is concerned. They are automatically assigned by the compiler itself. And yes, most importantly, these values are assigned only if your variables are not initialized. If you have initialized your variables, then it's perfectly fine. No garbage value shall be assigned to it. And auto, yes, they can be used only within functions. You cannot use them outside functions. So the next type that we have is extern. This is the default storage class for all function declarations and definitions. See, extern is the default storage class for functions, and auto or automatic is the default storage class of variables. So that is a major difference between auto and extern. Next, one more difference is that automatic variables have local scope, whereas extern variable is not only limited to actually local scope. If you declare some variable as extern, then you get two flexibilities. First of all, the first flexibility that you get is, if a variable is made extern explicitly, then it is just declared and not defined. Actually, this is a property that we use more often when we want to just declare a variable and not initialize it. So if you want to leave any variable uninitialized, then you must write extern keyword before it. Okay. For example, extern int var is not defined. That is how you declare variables without defining them. You may face this question anywhere in the interviews or as MCQ in the exam or any exam. Okay, so extern int var, this is an important point actually. And extern extends the linker visibility of functions or variables to the entire program. So this is what I was talking about. These auto variables have local scope, whereas external variables do not have local scope. Instead, their visibility can be extended to the entire program. Okay. The next type we have is static. Static variables preserve their value even after they run out of scope. So again, we have this discussion about the scope. So I've already told you what's the meaning of scope. Now static variables preserve their value even after they run out of scope. Now see, what happens is, if you have some function, say anything, say function ABC, inside that ABC you have some variable A. So as long as that function is under execution, the value of that A, or the value of that variable, will remain intact. But as soon as the execution is over, the value will be lost. Okay, that is what I told you earlier. But if you declare that particular variable as static, then the value of that variable will be preserved in the memory as long as the program execution does not terminate. So that is a very important application of this static keyword. Next we have, it is useful as the variable is preserved. Okay, this one we've already discussed anyways. So it is useful as the variable is preserved in memory instead of destroying and creating every time. Third point is, static when applied to global variable causes that variable scope to be restricted to the file in which it is declared. See, one thing that I missed out in extern was extern keyword. If you use the extern keyword with some variable, then you can link that variable with some other file as well. But in case of static, that is not so. If you use static with any global variable, then the reach of that static variable remains only within the bounds of that file where, or within the bounds of the program where that static variable was declared. You cannot have it, you cannot use that variable in some other file, unlike in the case of obviously extern. Next point is, when static is used on a global variable, it causes only one copy of that member to be shared by all the objects of this class. See, this is an important concept actually, but it is quite very much irrelevant to C, because in C programming language we do not have any concept of classes. The concept of classes only comes in C++ or beyond. So using some variable as static, it becomes very it is a very good tool that you'll be using later on again and again. And you will see that when static is used on a global variable, then only one copy of that static variable, say suppose A, that A will have only one copy throughout the program, and that same copy will be used by each and every say class or function or anything in that program. Okay, so that was the fourth point. And the last type of storage class is register storage class. Although it is very much important, but we do not use it much, because there are two reasons. First, that registers are actually very high speed storage. Okay, just like we have hard disk, we have RAM, we have cache. Similarly, we have registers. Obviously, the size of registers is very less as compared to maybe our RAM or hard disk. But then register is, see, the function of register is that it is used to define local variables to be stored in register. What is this register? Register is nothing but a block of memory. Okay, you can say it is a small block of memory. But one thing that you must note is that you cannot define local variables simply by writing register. What happens actually, what I mean is, the storage class will be assigned as that of register if and only if there is some register which is empty. Okay, if no register is empty at that point in time, this register storage class won't be assigned to it, because what happens is, register is actually a very high speed storage buffer. Okay, so this is used in order to maintain a coherency between the speed of the RAM and speed of your speed of execution. Okay, now if we are to use register, then it shall be used only for those variables which are accessed very frequently in the program, very frequently. Otherwise, it makes no sense to use up a register just to store a value which is accessed maybe only 3 to 5 times in the entire program execution. Okay, so that was another use for register which I've already told you. The second point is what I just explained. Next we have those variables. Okay, this one also I have explained. It is those variables which need to be accessed frequently are declared as register storage class. And lastly we have address of register variable cannot be obtained. Yes, this is quite obvious. See, when we have some variables in the RAM or maybe ROM, then obviously we can obtain the address of those variables by using pointers. We probably have not discussed pointers yet, but later on we will discuss pointers. You will get to understand what I said. So address of register variables cannot be obtained using pointers. Okay. For some other variables, you can obviously use pointers to determine the address, but not in the case of register variables. So now let's directly jump into code. So the first program that I would like to show to you is for the extern. So over here what I'll do is I have two files. First file you can see I have named it as main.c, and the second file I have named it as sub.c. So I'll be using these two files. In main.c I will write, first of all I have the header file hash include stdio.h. Then we have void print, which is a function. I will not give the definition of this function in this main.c. I will give it a sub.c. And why I'm doing that is to explain the function of extern keyword. So this is my main method, and inside this main method I'm just making a call to this print. So that is all for this main.c. Let us save it. Now I have sub.c. So let's try the same thing. Hash include stdio.h. Next we have void print. Let's say int count. Note that this count is the same count which we used in the main.c file, but over here it will show an error. Why will it show an error? I'll tell you in few moments. So count is equal to d comma say count. So this is our sub file. Now let's save it, and I will be running, or I will be executing this code via the command line, because over here we have two files and I could not find any option in dev C++ to execute two files together. So what I'll do is gcc is the command to execute the C code via this thing terminal, and I'll first write the name of the first file and then name of the second file. So gcc main.c sub.c. Now in this case it won't exactly show an error, but the output will not be the same as what you would expect. See, over here we are having int count is equal to 40, and over here we are just printing the value of count. So we expect that the same value should be printed inside this printf, but that is not so. Why is it happening? See, the value that has got printed is 4200811. Why did that happen? Because over here, if you must have noted, we have not initialized count by any value. So as I told you earlier, if we do not initialize it, then we will get any garbage value. But if I now initialize it, then you see what happens is we will get the count value as 29. Okay, that's it. We've got the value of count as 29. But what if we don't want to initialize it? In that case, as I told you, we'll use this extern. So the extern keyword is used to leave any variable uninitialized. And if you must have noted in main.c, I have given the initialization over there. See, I have written count is equal to 40. Now over here what happens is, see, I have declared this count in this file, in this main.c, and inside sub.c I have written extern int count. So what it tells to the compiler is that, okay, there is no definition or there is no initialization for this count variable in this particular file. So as soon as the compiler will encounter this extern keyword, what it will do is it will go to the associated file. and over here it can immediately see that yes, okay, there is a variable which is, whose name is count and the value of which is 40. Okay, so if I write extern over here, then the value 40 will be assigned. So let's clear the screen and gcc main.c sub.c. Now if you see, you'll see that the value of count is getting printed as 40. See, the value got printed as 40. But when we had not written this extern over here, the compiler had no clue about where did this count come from, and that's why it just assigned any random garbage value to this variable, and that is what was getting printed over there. Okay, now we will write one more program to be able to understand the static keyword. So I've given the explanation for static. Now we'll take a look at the program. Okay, so again let's write that same thing, hash include stdio.h. After that we have, say, a function, void func. Okay, let's leave it undefined out here with some void parameters. Let us make this static int count, let's say 5. Now I write a main while count minus minus, go inside the loop and make a call to the function. Don't worry, I will obviously write the definition for this function. Now what I'll do, I'll just make a call here and terminate. Now if we have something called func, we obviously need to specify the definition for it. Now I'll write int I is equal to, say, 5. Okay, first of all let's do static int I is equal to 5. Now I will increment this by 1, and after incrementing I will write a printf. So printf I, say, okay, let's say I is %d and count is how much %d. Okay, let's put a new line, I comma count. So that is the value that we are trying to print. Let's save this file as static.c. Let's save it. Now if the code does not have any error, if no error has crept in, then we must expect the output as we want. So over here what's happening is, okay, let's see, what do we have? I is 6. Why is the value of I 6? Okay, yes, I is 6. Then we have 7, 8, 9, 10, 11. So over here the value is 4, 3, 2, 1, 0, minus 1. Okay, we can ignore this actually. So if I ignore this line, then what I'll get is, probably we won't have that line at the end. Yeah. Now see what's happening. I have declared this count as a static variable, and over here also I have declared I as a static variable. So initially the value of I is 5 and that of count is also 5. But over here inside the while loop, what I've written count minus minus. So that means the value of count will be decremented by 1 to give a 4. Okay, so we get a 4 over there. Now once that is done, okay, this will actually continue repeatedly. How long will it continue? It will continue until the value of count does not reach 0. Now inside this definition, func definition, I have written static int I is equal to 5. So the purpose of writing static was that the value of I must not get changed again and again. What I want to say is, see, in this case we have static int count is equal to 5, static int I is equal to 5. See, I is 6, count is 4. Obviously count minus minus will change it to 5 minus 1, that is 4, and I plus plus will change the value of this 5 from 5 to 6. So that's why we have got 6 4. Similarly 7 3 8 2 9 1 and 10 0. So that is what we are getting. Now say suppose you don't have this static, then what will happen? So in that case we won't get the value of I incremented again and again. See, the value of I has become fixed, that is it is now fixed to 6. Why 6? Because this part is working as it was working before, but from here I have removed the static thing. So as soon as over here we have made a call to this function, as soon as this function execution is over, the value of I will be removed from the memory. Okay, so the compiler no longer knows what was the previous value. So if the compiler does not know the previous value, then obviously it will print 6 6 6 6, because over here we have 5 and I plus plus will be able to give only a 6. So that's why we have written, we have got the output as 6 6 6 6. Okay, whereas we made no change to this count, and hence we got the output as 4 3 2 1 0. So that was the use of this that was the use of this extern and this thing static keyword. Now one more thing that I would like to tell you is that, see, over here we have a print function, okay, but I have not written any extern before that function. Why is it so? Because extern is the default storage class of any function, that I have already told you. So extern is the default storage for any function. Okay, so extern. And automatic, as I already told you, that if you want to make any variable as automatic, we do not need to specify it explicitly. It is automatic beforehand, okay, or by default the storage class that is assigned to any variable is automatic. So that is all for this video. Thank you.